Welcome to this explainer. We're going to totally demystify the black box of large language models today. But instead of getting bogged down in all that complex math and code, we're taking a completely different route. We are going to take a tour of the futuristic AI city that powers these incredible systems. Because honestly, understanding this architecture, that's the real key to unlocking AI's true potential for your business. We're going to follow a single prompt on this wild, incredible journey from your keyboard all the way to the final generated answer. Let's get into it.
It's wild to think about, but everything really does start with a human intention. Whether you're just typing out a quick factual question, like asking for the largest country in the world, or you're requesting a complex generative task, like drafting up a formal salary increase email, your keystrokes are the spark. Just that simple tap of the send button literally ignites this massive, highly coordinated digital infrastructure. Okay, so let's look at our city map and actually trace your prompt's exact hero's journey. It's going to travel through 5 highly specialized corporate departments. We'll start at the AI city gates, then move into the translation department, head over to the mission control center, visit the master writer, and finally wrap up with the quality assurance team. All right, kicking things off with phase 1, the AI city gates. This is where we deal with the user layer and that all-important initial safety. So our journey begins the absolute millisecond you hit send. Your request arrives first at the massive gates of the API gateway. Think of this kind of like a corporate reception desk. It handles all the authentication, checking who you are, it manages your session, and it enforces rate-limiting protocols, so the whole system just doesn't get overwhelmed. Basically, its main job is taking your raw text and neatly organizing it into a validated, secure digital request package. Now, right past that reception desk is an immediate safety filter. Think of it like an airport-style security scanner. This checkpoint is absolutely crucial for distinguishing a normal user request from a malicious attack. It detects harm and blocks those sneaky prompt injection attacks using secure, signed prompts. It's basically ensuring that only safe, legitimate instructions actually enter the AI city. Once you're safely cleared by security, your prompt is rushed over to phase 2, the translation department, which handles tokenization and embeddings. This department is actually essential because, surprisingly enough, the AI cannot read English, or any other human language for that matter. To even begin to understand your text, the system has to first run it through a language scanner, converting it entirely into a purely mathematical token stream of machine-readable symbols. And what's really fascinating here is the precise pipeline used to slice up your request into these tokens. First, it normalizes the text, standardizing the capitalization and punctuation. Next comes pre-tokenization, which breaks it down into rough chunks. And finally, the actual tokenization kicks in. This commonly uses an algorithm called byte-pair encoding to merge highly frequent characters into distinct subwords. So, as you can see mapped out, the tokenizer slices sentences into these highly frequent chunks. A word might be a single token, or it might actually be split into several little pieces. Processing these pieces as distinct numerical IDs, that drastically improves the system's speed and overall efficiency. But here's the thing. Raw numbers aren't quite enough. To give these numbers actual meaning, they get converted into what we call embeddings. Think of this as plotting your words into a vast, multidimensional digital galaxy. It maps the relationships and definitions of your words, allowing the LLM to really grasp the deep, subtle context of your request, way beyond just a basic dictionary definition. Okay, with the text fully translated, it arrives at the absolute brain of our operation. Phase 3, the Mission Control Center. This is where intent, orchestration, and retrieval all happen. Right here, an orchestrator analyzes this newly created task blueprint to figure out exactly what external help is needed. Depending on your specific prompt, it activates specialized subdepartments or tool agents. Like if you asked it to calculate 27 times 48, it taps the calculator agent. Need current events? It pings the web search agent. You get the idea. To see how this builds, the orchestrator actually scores the intent of your prompt to route it perfectly. For example, it might know with 98% confidence that a question about geography absolutely requires an external database search for factual accuracy. Meanwhile, it knows drafting a professional business email, that doesn't require outside search tools at all. And this is exactly where the system gathers context. It pulls from standard memory to remember what you were just chatting about 5 minutes ago. But if factual, up-to-date knowledge is missing, Mission Control deploys something called Retrieval Augmented Generation, or RAG. This is literally like sending a team of AI librarians deep into a corporate archive to pull highly relevant, factual documents before the actual writing even begins. It's a real game changer because it drastically reduces the chances of the AI hallucinating or just making things up. Armed with all that intent, memory, and research, the execution plan is finally handed over to Phase 4, the master writer, diving into the core LLM and its attention mechanisms. Now, what makes this writer a true master is its self-attention mechanism. Rather than blindly matching exact keywords like a traditional old-school database, the master writer analyzes how important every single token is relative to all the others in your sequence. It essentially maps out long-range dependencies to understand the true nuanced context of your sentence before formulating a reply. And crucially, in modern systems, this master writer isn't just one massive monolithic brain trying to calculate everything all at once. No, it uses what's called a mixture of experts architecture. Basically, a smart routing gate selectively activates only the most relevant expert subnetworks to process your specific tokens. This clever design doesn't just speed things up, it saves massive amounts of compute power and operating costs. So, combining all the gathered context and that expert processing, the autoregressive engine finally goes to work. It simply acts to predict and assemble the most mathematically probable and appropriate next words. It drafts the response for you, token by token, constructing the perfect answer one piece at a time. But wait, the drafted text isn't quite done yet. We have to make a final stop at Phase 5, the quality assurance team, for a strict evaluation and safe delivery. Like a team of meticulous corporate editors, the response evaluator and safety review modules scan the newly generated draft. They're checking for logical consistency, ensuring the model actually followed your instructions to the letter, and most importantly, they run strict policy compliance checks, looking to redact sensitive information and mitigate any safety risks, so the final output is completely unbiased and harmless. Only after passing these final, rigorous checks is the response translated from those math tokens back into human text and delivered straight to your screen. From the city gates, over to the master writer, and back again. An incredible, invisible journey of millions of operations and thousands of experts, all happening in less time than a single heartbeat. You now know exactly how this AI city works. So, what will your next prompt build?